Hi again, guys. I'm going to do a quick empirical and molecular formula practice, and hopefully the microphone is a little bit further away from my face now so you don't hear me breathing like I just ran a mile like in the last video, but you know what, so it goes. Let's start by looking at some practice problems about empirical formulas. So the first example we're going to do has to do with, it's giving you the percentages by mass, so it's basically giving you that percent composition of all of the elements in the compound. Here we have barium is 58.8%, sulfur is 13.74%, and oxygen is 27.43%. So based on these percentages, I'm being asked to calculate the empirical formula. So remember how we're going to go about this, so the flow chart of how we're going to do this. So first thing we're going to do is we're going to convert from percentages into grams, and I'm going to do that by assuming 100 grams. And this will allow me to basically just turn those percentages that I'm given directly into grams. So barium becomes 58.8. This thing is terrible at points. 0.8 grams instead of percent. Sulfur becomes 13.74 grams instead of percent. And oxygen becomes 27.43 grams. Let's say grams. Okay, so that's the first step. I'm going to go from percent to grams. Then I'm going to go from grams to moles. And then from moles to mole ratio. And it's that final mole ratio that's going to allow me to get that empirical formula. So just a quick reminder, going from grams to moles, you can think back to your mole map. I'm going to use the definition 1 mole of something equals blank grams. And in the case of elements, I get this straight off the periodic table. So I've already done the first step, going from percent to grams, by just assuming 100 grams. Remember, percent literally means per 100. Cent is 100. So if I have 100, then each number is per 100. So 58.8 grams of barium, how am I going to convert that to moles? Well, I'm going to use my definition of the mole, which is 1 mole of barium is equal to 0.33 grams. And I got that straight off the periodic table. I'm going to do the same thing for sulfur, so I'm going to multiply by the mass of sulfur, so 1 mole of sulfur is equal to 32.06 grams. And then the same thing for oxygen, so 27.43 grams times 1 mole of oxygen is equal to 16.00 grams. Okay, so grams cancel out, giving me moles for all of them. And what I get is that I have 0.482 moles of barium, 0.4, I'm sorry, I don't see an eraser on here. It's supposed to be 428. Sorry, 428 moles. 0.428 moles of sulfur and 1.714 moles of oxygen. So now I've converted them all to moles. To get that mole ratio, I'm going to divide them by the least number of moles, which is the same for both sulfur and oxygen. So I'm just going to pick sulfur because it's exactly the same. So now I'm going to divide each one of these numbers by the least number of moles. So divided by 0.428, divided by, not so much room here, 0.428, divide this by 0.428. And what I'll end up getting, and I'm going to write it on this side because I've run out of whiteboard, is that I have a 1:1:4 ratio of barium to sulfur to oxygen. So how do I write this as an empirical formula? I simply write each of the elements. So Ba1, the 1 is implied, so I don't write anything. S1, the 1 is implied, and then O4. So BaSO4 is the empirical formula of this compound. So I'm pretty bummed because I just spent like a lot of time trying to pre-write this slide, and I guess I didn't realize that if I moved it would erase it, so you're going to have to deal with me writing it out again. But here's another problem where I have to go from percent composition to empirical formula, and then I need to make another step from empirical formula to the molecular formula. So again, we're going to start by converting these percentages into grams, and I'm so mad because I literally just wrote this all out so I didn't have to do this, but here we are, so let's do it. So carbon is 65.45 grams. Hydrogen is 5.492 grams. And oxygen is 29.06 grams. And again, I got that simply by converting those percentages into grams by assuming a total mass of 100 grams. In order to convert these to moles, I'm going to multiply by the molar mass of each of the individual elements. So for carbon, I'll use the definition that 1 mole is equal to 12.01 grams. Hydrogen, I'll use the definition that 1 mole is equal to 1.01 grams. And for oxygen, I'll use the definition that 1 mole is equal to 16 grams. And that's just because that's what's on the periodic table that I'm using right now. Not the most significant figures, but you get the idea. So I can end up converting these, and what I get is 5.449 moles of carbon. I get, that should be an equal sign. 5.437 moles of hydrogen and 1.816 moles of oxygen. So now I have the total number of moles for each one, but I don't need that. What I need is my mole ratio. Once again, I'm going to divide these by the least number of moles. So it's going to be 1.816 divided by 1.816 divided by 1.816. So again, all I'm doing is dividing by the element that had the least number of moles. And that will give me my mole ratio. So what that will give me is the carbon ratio will be 3, hydrogen will also be 3, it'll be 2.994 and I'll round up, and oxygen will be 1. So once again, how do I convert this into an empirical formula? I simply write down the elements, so it would be C3H3O1, where the 1 is implied. But they didn't ask me for the empirical formula. What they asked me for is the molecular formula. So now I have to remember that the molecular formula is a multiple of the empirical formula, and in order to calculate the molecular formula, I need to know the mass. So here they've given me the mass of the actual molecule. Using the empirical formula, I can find out the mass of the empirical formula, and then I can use the ratio to find out the multiple that I need to add. So let's go ahead and erase that. So I believe my empirical formula was C3H3O. So let's find out what the mass is of that empirical formula. So that would be 3 times carbon, so 3 times 12.01 plus 3 times hydrogen, 3 times 1.01 in the interest of time, plus 1 1 times 16.00. So this will give me the mass of the empirical formula. And when I did that math, I got 56.06. I'm sorry, 55.06 is the mass. So what that means is 1 mole of my empirical formula is equal to 55.06 grams. So now remember, I want to get the ratio that I need to multiply this empirical formula by, so the multiple, I'm sorry, that I need to get to multiply this by, and I'll get that by finding the ratio. So I'm going to take the actual molar mass, right? So actual divided by the empirical mass, and that will give me my multiple, and then I'll use that multiple to calculate my actual molecular mass. So 110 divided by 55.06 is going to be a ratio of 2 approximately. So I'm going to multiply all these by 2. So I will have C6H6O2. And that's my molecular formula. Okay, not so bad.